I think PTA is trying to get in. All right. Let me switch over, get right to it. Good news today, guys. We're only going to do, I think, 66 slides, maybe. I'll fly through them too. And then we got a little bit of homework um, for tonight or tomorrow, whatever you want. We're into the define phase, part one. So the 3 weeks of define. And just, I know we saw this yesterday. Oh, let me let people in. Sorry. Yeah. I thought the Hubbard Hall people were never late. I got a couple of them late, Megan. What's going on? They're always early.
Always 5 minutes early.
Oh, yeah. Yeah. Adult Parcells. Um, so just a quick review. The green
You
belt,
can't even hear me.
the green belt is recognize your ability to identify opportunities, quantify, analyze cause and effects, implement valid solutions. We saw this in our meet and greet. Just a quick review, though, of why you're here and what, once you have your green belt, what you can do. Support or lead improvement projects, mostly in a part-time role. There's a few people probably that are going to want to do it full-time, which is a really fun way to make a living. And thorough understanding of the DMAIC, which we're going to get into today quite a bit. And then, of course, understanding and using some lean tools. And I think I skipped one. No, I did not. So here's the define phase. Again, we broke it into three phases. I mean, 3 different weeks. We're going to go through the DMAIC approach, define, measure, analyze, improve control, do some history, a little bit of voice of the customer, what all the belts mean, that kind of stuff today. And we'll cut it off at I think it's 69 very fast slides. Then we're going to segue over to Excel, and we're going to go through how to do a Pareto chart, which is pretty fun, pretty easy. I think you like it. And that'll be our homework. And next week we'll be into cost of poor quality. I'm still letting people in. I apologize. And basic Six Sigma metrics and how to put together a business case and a project charter and all the administrative parts of project management. So a lot of project management stuff. And then my favorite tool, which is failure modes and effects analysis. We'll cover that next the third week of Define, and then we'll get into some lean. So again, just a reminder, this is kind of the way the course is broken out, but it's also such a powerful way of thinking about problem solving. Before we can do anything, we got to make sure that we can define what the problem is and the objectives. And then we got to measure it somehow. So we have to quantify it, put that problem in numbers somehow. That's the hardest part usually. How can we measure it? And then once we've done that, then we can analyze those numbers. And then we can do improve control, which get really, really easy. And the key is that I put the term nimowashi there. That's a Japanese term, kind of sushi. Not really. It's not really sushi, but it means proceed slowly, consider many options, gain agreement, implement rapidly. Right. And that's the kind of the way the H3 process, you should think about it, is define, measure, analyze, proceed slowly, consider many options, gain agreement, implement rapidly. And this is kind of the MAIC is something that's used in Six Sigma a lot. In Lean, we also use plan, do, check, act, which is a circle, which we're going to constantly plan, do something, check it. Did it work? Do it again, over and over. So the MAIC is how the course is laid out, as you know. So we're into Define right now, part one. So the basics, Six Sigma, Define is we got to figure out what those requirements are that are critical to quality. What does our customer want, right? And then we're going to get into a cool formula. We're Y is a function of X's. Um, talk about that. We got to gather data to measure the performance of our whatever process we're interested in. Then we got to analyze it. Then we got to improve it. Then we got to control it. So the define phase, which we're getting into, it's about selecting high payback projects and identifying the metrics that we can use to improve it. And it's probably the most important part, like of any project, because we got to figure out, all right, what do we want to work on? Can we all agree? That, and I think the measure phase are the two most important. But it's a solid foundation. What's the scope of it? What are we including? What's our problem? And getting everybody on the same page to understand what we're going after. And we have to do it from here on in, we got to do it in a quantifiable manner, which means we're going to put numbers to it. How often? How many? How long? Um, we got to be able to quantify it. It's not just enough to know about it, but we have to quantify it. And this is one of my favorite quotes of all time, by this brilliant guy, William Thompson, Lord Kelvin, his name was. When you can measure what you're speaking about and express it in numbers, then you know something about it. But when you cannot measure it, when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. So that's the theme, going through your whole Greenbelt class is how do we figure out a way to measure it? And I got a lot of people on here that have done A3. And again, that's usually the biggest challenge is let's go figure out how to measure it. So that's what we do. So part of what we do in the define phase is there's some deliverables. And again, keep in mind, guys, that when we talk about a Six Sigma project, historically, those have been 6, 8, 10-month long projects that include a team with a master black belt and a black belt and maybe 5 black belts and just huge team, very slow going. And and so generally you need to have a lot of paperwork, right? I got to justify what we're doing. So these are some of the deliverables when you're doing a long Six Sigma project. Um, a business case, a problem statement. We're going to cover those more next week in terms of if you wanted to do them. But keep in mind, we don't generally, I think we've kind of gotten away from doing these long projects. Like I think, the way things are done and the way Toyota taught us, with lean is if it's a big project, let's turn it to small ones. But occasionally you might have a big, long project. So you would need some of these deliverables, including a stakeholder assessment and high-level Pareto chart, and voice of the customer, voice of the business, critical to quality, all those things that we're going to talk about. Because you might need some money. You might need to invest in outside services, or you might need to invest in, people being off their regular job for a while. So, but just so when after you got your green belt, this is why, all these deliverables are covered. And we're going to, again, talk about them a little bit more next week. So what is Six Sigma? It's a whole bunch of different things, right? It's a Sigma. It's what we're talking about is lean is talking about taking waste out, and Six Sigma is talking about taking variation out. Can we get the same answer over and over? Is it predictable? Is our process predictable? Is it consistent? Is it the same every time? So lean is waste, and the 8 waste we'll cover. You guys know that, but we're going to cover it again. And Six Sigma is variation. And they work hand in hand pretty well. But Six Sigma, it could be a measure of variance. It's a process measurement, what you'll see, because I can measure the number of sigmas, which is really another word for standard deviation. It could be a business strategy. It's a methodology. It's a philosophy. It could be a Six Sigma project. It could be Six Sigma tools. So there's a whole bunch of definitions of what is Six Sigma. And so what is it? Measure of variance, right? A sigma is standard deviation, which when we get into descriptive statistics and we practice doing, bell-shaped curves and averages and stuff, basically a sigma is, and standard deviation is what's the average away from our average? That's all. That's all it is. It's a measure of variation though. So variation is the enemy of any process. So we need to be able to understand and manage it and minimize variation. It's an aspiration or a goal. And Six Sigma means that I'm only going to have less than six standard deviations away from what it means is a very consistent process. We're gonna dive into that big time. So Six Sigma performance, if something is working at a Six Sigma level, that means that my defect rate, I'm going to skip over that. The defect rate is 0.0034%, which means if I run the process 1 million times, I'm going to get 3.4 defects. So all of a sudden, like, let's take PTAs on, you guys, right? Coming off the molding machine. I'm going to do a million of them, and out of a million, I'm going to have 3.4 that have a problem. That's Six Sigma level quality. It's 99.9997% yield. And then if I go down, let's jump down to 3% Sigma, three Sigmas, then I'm looking at 66,810 defects for every 1 million opportunities. All right. So that's about and the cost of poor quality in the right column. When I'm at Six Sigma, I'm looking at a cost of poor quality, which comes right off our ability to pay people, give bonuses, make money, comes right out of our profit, is less than 10%, right? When I get to Three Sigma, and it's hard to believe, but it's been proven truthful over and over. If I'm at Three Sigma level, then my cost of poor quality, which is money that comes right out of our profit, our ability to pay people more, give bonuses, all the stuff we love to do, its cost of poor quality is about 20 to 30%, right? So the higher the Sigma level, the lower the defective rate and defects per million opportunities. 3.4 defects per million opportunities. So let's say we are at Three Sigma, which is about 93% yield, 66,810 defects per million opportunities. Virtually no modern computer would work. 10 million healthcare claims would be mishandled. We lose savings bonds. Checks would get lost by a single bank. 4,000 invoices would be sent out incorrectly. The one I love is the luggage. It gets sent to the wrong place. 270 million, at the airport, after they check your bag, they send it somewhere else. Um, just really not a high functioning processes. And a 1% defect rate, it'd still have 20,000 lost articles of mail, unsafe drinking water, almost 15 minutes a day, 5,000 incorrect surgical operations per week. Short or long landings at the airport. Ooh, that don't sound good. Wrong, 200,000 wrong drug prescriptions. So even at a 1% rate, some processes would be unacceptable to all of us. Now, we talked about Six Sigma is a lot of different things. It's also a philosophy. It's that of continual improvement through the use of data and specific variation reduction techniques. So just taking our variation out of the processes that we do every day. And a competitive advantage is definitely gained by meeting customer expectations and exceeding them. And it's probably the most efficient and effective way to do it is using Six Sigma. I think I just want to do a little editorializing on this thinking because, in this day and age, even if you all had your own business, if you said, hey, someday I want to have my own business, in our day and age, it is not okay to satisfy our customers. Satisfying our customers means that they get what you told them you're going to get them on time, perfect quality, all that stuff you really can't put on your website because that's what you're supposed to do. That's why they're paying us. We have to continuously figure out ways to delight our customers. And that is do more than the other current offerings, our competitors. And again, the Six Sigma and Lean is a way to, if you make it part of your business plan, it's a way to delight versus satisfy. And a bunch of tools. Six Sigma is also a bunch of tools, which you guys are going to get ad nauseum over the next bunch of weeks. All kinds of tools. So again, there's a lot of definitions when you say what's Six Sigma, could be the tools. There's just a few examples of them. And it's a business strategy, links the outputs of our processes to the expectations of our customers. Customer says they want it, X, Y, this is what we need. And we figure out a way to make sure they get it every single time exactly that way. So the problem-solving strategy, the Six Sigma approach, we talked briefly on. I'm going to dig a little bit farther into that. And it's a beautiful equation. And it's Y is a function of X's. Pretty simple though, if you think about it, right? So it's a cause and effect model. If I want to change the effect, then I got to focus on the causes, right? The effect is dependent on the causes. So the first step when I want to identify in a process the causes and effects is for the effects, I got to identify the customer requirements for the process outputs. What do they want? How big, how often, how many, how small, what are the dimensions, um, all that kind of stuff. And once I've done that and quantified it, put it in numbers, and then I'm going to look for some of the ways that I could control parts of the process to deliver that. Simple enough, right? And then we establish specific and measurable characteristics of the company customers' requirements, CTQs, critical to quality. These are things that they can't live without. And then we prioritize by the customer the requirements and identify which processes impact those characteristics, prioritize and streamline process efficiency, and we identify the critical inputs by those that have significant influence on the product. And two, the ones that don't, get rid of them. We're not going to measure those. And generally the good news is, this idea of Y is a function of X, we're usually only talking about a few X's, 3 to 5 generally are the things that are going to impact my Y. Let me go back to this equation. So it's like when we look at the X's, all these X's are going to cause Y. It's generally going to be 3 or 5 critical ones. And then the rest of them we just throw out. And then those are the ones we want to measure like crazy and then go through the whole DMAIC with them. So this is kind of redundant. I'm going to send you the slides, so I'm going to skip. But this is kind of gets into the Y. And this gets into the X a little bit more. So the function fx, it can transform inputs X into output Ys that meet custom requirements. And these can be business system, processes, sub-processes, steps, whatever. And that's a transfer function. F is a function of X. And we got to identify, the key is in the define phase, we got to figure out what those critical input X's are that have the greatest influence on the Y. All right, so that's part of the define phase is what are those things that we can change to get the Y we want. Here's an example. Let's say I have a pizza delivery company and I want to meet customer expectations, right? Means I want to be on time all the time because people do not like eating cold pizza. So the measure would be Y would be our percent of on-time deliveries. That's what we're measuring, right? So that's our dependent variable. Now the X's things that we might consider might be things like traffic at certain times of day, the number of deliveries that we give each driver. We have a bunch of drivers. The accuracy of directions that we give the driver. Maybe the condition of the vehicle, whether it's on its last leg. And those are all X's that could tie into people getting hot pizza or not. So a whole bunch of X's, and again, vital few X's that are gonna influence my on-time delivery for pizza or whatever my process is needed out of it. Everybody wake still. This first couple of weeks we just go through a bunch of these, try to make it as painless as possible. So this approach to problem solving, we're going to look at a bunch of X's. And again, a common theme in continuous improvement is we can't generally get to the right answer by ourselves. That's why we do A3. That's why we have teams. That's why people are together all the time, because we need to brainstorm. We need to use every brain in the company, right? Because it might be 100 X's that people come up with. And the trick is going to be, how do we get to the vital few factors that are really, truly going to move that Y, right? In this case, the pizza being hot. It's a very powerful concept. Let's say we're working on a problem on time delivery, or let's say productivity, pick one, scrap rate, anything you want to measure. We don't want to measure 500 things to kind of move. We got to figure out what are those vital few factors and then control those so I get the answer I want. All right, now that we got that out of the way, let's get into a little bit of history. This is the history of Six Sigma and continuous improvement. There's a timeline, 1900, the principles of lean manufacturing begin to take shape. And that's pretty much in the form of Toyota and their development of the loom. The loom, I said it. You guys saying what? Yeah, Toyota was the best in the world at making looms to weave cloth. And they came up with the very first self-stopping loom. This is before Toyota, when all the fabric got tangled in the loom, it was hours and hours of backbreaking work, taking everything apart and untangling the whole 9 yards. What Toyota came up with, and that really bothered Toyota, it bothered the grandfather. Um, and he came up with one that as soon as it got caught, it would stop immediately. And the reason he did it is because it used to get him upset to watch people wasting hours of their life untangling fabric. And that's where the concept of judoka comes from. It's a lean term, but it means respect for people. And the reason why he did the self-stopping loom is because he decided it's a waste. We shouldn't waste 1 minute of a person's precious life taking apart a loom. And then, so Toyota started going, beginning, and then he got with he watched they were fascinated with Henry Ford and the assembly line, through up to 1975, 1980, and Toyota, particularly during the oil embargo, when people were buying small cars instead of you know, the the room size cars that my father had, many of us back in the day. But the thing was, they never broke. Those vehicles, even the one my father bought, he had the seven of us in a house, and we couldn't even ride together. But he got one of those Datsun V210, which is now Nissan, and you could only fit like three people in it, four maybe if you're lucky. But they didn't break, right? And so everybody started studying Toyota and saying, "Why is this? How come they don't break?" So Toyota invited everybody over, General Motors, uh, Ford, Chrysler, invited them over to Japan and taught them, what we teach as lean principles, Toyota production system. And they still didn't get it for a long time. And then in the mid 80s, late 80s, early 90s, Motorola started toying around with Six Sigma, and it got a lot of attention because they were making claims that, they're saving 8, 9 million dollars, 10 million, $20 million using this Six Sigma as a business strategy. And then it really, really got hot when General Electric and Jack Welch was on 60 Minutes talking about all the money they saved doing Six Sigma at General Electric. And when that happened, everybody and their brother, they started certifying black belts to everybody, and it got to be a big industry and the whole 9 yards. And when I started my lean journey at Duraflex, I actually thought that's what I should do too. So I got certified as a master black belt. Then I realized Six Sigma, you can't solve every problem with Six Sigma. It's way too much work. And we don't need to attack every problem with like this. So, a good diet of lean, 70, 80% lean, and then having, 20% in your hip pocket to be able to do some tools for variation. I think that's a really good mix. And now, so a lot of people for a long time, they expanded their Six Sigma departments. Everybody had master black belts. That's what they did for a living. And now it seems like it's kind of gone to the wayside quite a bit. But if you go on LinkedIn and you want to get yourself a black belt at some point, you'll still see, show me jobs for black belts, and there's a high dollars, it's good compensation, and they're all over the country still, but mostly it's going to be the bigger companies that you'd work in. And so Bill Smith at Motorola, he's kind of the father of Six Sigma. And in the 80s, they applied it as a process management discipline throughout the company. And they started a Motorola University. And then they got the Heisman Trophy of Quality Awards. They got the Malcolm Baldrige National Quality Award. And then, like I said, Jack Welch made it fashionable when he was on 60 Minutes talking about the millions and millions and millions of dollars that General Electric saved using Six Sigma. All right, now let's get through the belts a little bit. So, four belts, pretty much. Um, and they represent a different level of learning and expertise. Master black belt, green belt, and yellow belt. And we're going to go through those a little bit more detail each. And then there's other roles in a company that help do Six Sigma projects. You have champions, someone that wants to champion a project and make it go. You might have sponsors, stakeholders, and subject matter experts. So the Six Sigma discipline is organization wide. It's an important part of a Six Sigma success is leadership support, and that goes for lean too. Also, if the owner, manager, supervisor isn't involved and engaged in it in some capacity, then it's just not that important, right? People want to do what's important to their boss. If the boss doesn't demonstrate that something's important, then they're gonna do whatever's important to the boss. They want to get caught when the boss comes around. I want to get caught doing what you think's important, boss. That's how we are. That's human nature. So leadership by example is, it's hard to delegate continuous improvement if you're a leader. Okay. I want to encourage and reward individual initiatives. I want to align incentive systems. And a bunch of people on this call, I think Ulbricht's on, PTA right now, I think too. Where basically when you get reviewed, there's a certain expectation that you're going to participate in continuous improvement, which is, I think it's a good thing. As a leader, I have to eliminate functional barriers slash silos, helping people get access to IT, maintenance, whatever they need, right? Finance sometimes. I need them on projects. As a leader, I want to embrace system thinking and I want to balance standardization with flexibility. And that's leading by example. The executive leadership owns the vision for the business, obviously. And whether it's Six Sigma or lean business strategy, they're going to provide sponsorship. Say, yep, this is what we want to do. Let's get it done. And set expectations also. Executive leaders enable the organization to apply Six Sigma, then monitor the progress against expectations. They set meaningful goals for us, performance expectations, etc. And then champions and sponsors are those directors, executives, senior leaders that are chartering, funding, or driving projects that the black belts and green belts are doing. All right. And again, think about it, guys. This is in a company that uses Six Sigma as a way of doing improvements, right? Most everybody on this call is lean / Six Sigma, I think, or maybe lean / Six Sigma, something like that. But champions and sponsors play critical roles. People want to do what's important to the boss. Typical responsibilities: maintain strategic oversight, establish strategy direction, clearly define success, provide resolution for issues, establish routine toll gates or project reviews, clears the path for solution implementation, and assists in project team formation. And I tell you, what I do for a living, I work in a bunch of companies, and Greg Boucher, who's the CEO at Ulbricht Steel, every year he comes up with his expectations for operations, and it's exactly what we need because it's basically a game plan for how we're going to roll out the coming year, in terms of continuous improvement. Master Black Belts. This is the most experienced, educated, and capable Six Sigma experts. In terms of hours, when we talk about black belts, it's generally about 60 hours worth of training, plus multiple projects that you would do in order to get the Master Black Belt level. But you've managed dozens of black belt level projects. You can lead a bunch of Six Sigma belt projects, mentoring, certifying others, that kind of thing. And they work with senior leaders, operations directors, and business managers. Um, not a ton of them around anymore. They used to be churning them out. They advise the management team on the cost of poor quality of an operation, and then typical responsibilities are they have a bunch of projects that support the business strategy. They establish scope, goals, timelines, and milestones. And again, a big part of what we do out, all of us is, and I encourage you guys too to start doing it, is let's find, train, and mentor the next generation of not only green belts and black belts, but lean thinkers. Um, the black belt, I've had many people that have taken this class say, "Hey, I want to get a black belt." It's probably the most active and valuable experienced Six Sigma professional of all the belts. It's most often, a little more prevalent. Black belts led multiple projects, trained and mentored various green belt candidates. That's why I can certify you guys because I'm a master black belt. Once I have a black belt, I can train others. It's well rounded in terms of a whole bunch of things: project management, statistical analysis, finance. And again, it's about 60 hours. The green belt, what you're doing now, is 30 hours total, and we'll get to that in a second. But it's a dedicated resource. Most companies now, they used to hire black belts, and that was what they did, 40 hours or 50 hours a week. Um, Gotten away from that quite a bit. I mean, even master black belts, they have a real job, and then they do this to work on continuous improvement projects with people. And there's the typical responsibilities. And what you're going to see when we get into the green belt, there's not that much difference. I mean, most of what you're going to learn, if you decide, hey, I want to become a black belt and you go on to the next step, um, it's not going to be that much more. It's not, it really isn't in terms of you're going to get most of it as a green belt. There's some other responsibilities, task management, team management. You're going to get the slides, so don't worry about it. I don't think much is, if anything's on the exam. So the green belt, that's us. It's a less intense version. I would argue with that. Um, Pretty much all the aspects of Six Sigma, minus we don't do any design of experiment stuff. You know, Maybe there's a little bit more theory, statistical theory as a black belt, but most of what you're going to get over the next 12, 13 weeks, oh, it's going to fly by. You'll see. Um, you can go ahead and go do your black belt right away, pretty much, because you're going to be ready to roll. Um, Green belt almost has the same responsibilities in project management. And I'm going to argue with the last point that less complicated and challenging because complicated means, do I have the right people to help? If it's really complicated, then I got to make sure I have the best team. I need all experts on my team. That's all. There's the same responsibilities pretty much, right, that you saw with the black belt list. And again, I hate to keep repeating myself, but I'll give you the slides. You'll have all this. But this is what we talk about is typical responsibilities of a green belt. And the yellow belt understands basic objectives and methods of Six Sigma. I got a bunch of yellow belts on this call, in this class. That's 15 hours of instruction and study and learning. The way this class is broken out, so 30 hours, if we're together, excuse me, 12 or 14 times, you got homework. You're going to be prepping for a little bit of a project, an exam. You add it all together, and roughly you're going to be spending around 30 hours dedicated to self-improvement. Yellow belt's about 15 hours. And one of the things I think I like is just getting as many people in the company at the yellow belt level. I know PTA's done a lot of it. Marion's on. They're doing it right now. We got a pilot set going through. Hubbard Hall. We've got a second set of yellow belt class coming up in a couple weeks that Megan Lynn and I are going to lead. She's on this call. But again, it's spreading the gospel of lean and Six Sigma. And the way I teach is with planes, so Legos, try to make it fun. How many, right? You got guys that have done it. It's kind of fun, right? Beats PowerPoints. So here's the typical responsibilities of a yellow belt. And yeah, stakeholders are the recipients or the beneficiaries of the success of a Six Sigma project. They own the process. You know, they're the people that work the machine maybe, or they work in the lab, or um, and we need to keep strong working relationships with stakeholders. I'm going to even go from my put my lean hat on, and my lean hat is that I am not qualified as a master black belt to fix your process. I don't work your process. You know your process. Respect for people means it's disrespectful for me to fix your job. So the trick is, it's not a trick. I just have a strong working relationship with respect in order to do any kind of meaningful process improvement. Subject matter experts, experts of the process or the subject matter. We like to have those sometimes on our teams. For a great example might be somebody that's good at an IT that I need is a subject matter expert. Sometimes I might need someone in maintenance on a team to help, someone in purchasing. I need people that are experts in the subject matter as part of our problem-solving teams. All right, project team selection. Um, Again, you guys all know how to do an A3 project team selection, 3 to 5 people. Generally, when we're doing a long-term Six Sigma project, it might be a lot bigger team. Um, if you decide you want to ever do one of those, but shared goals, commitment, leadership, respect, effective communication, all the stuff that, kind of comes naturally to most of us once we've been doing this for a while. We're on a lot of teams, A3 teams. There has to be some autonomy and diversity of thinking for sure. Everybody comes from different backgrounds and ways of thinking about things. And I think it's a common theme as we get into a lot of the tools you're going to learn. Not many of them are tools that should be done alone. I need to leverage that diversity of thinking of people. And all right, the fundamentals. Let's talk about voice of the customer. So the voice of the customer is a term used for data-driven plan to discover customer wants and needs. What does the customer want from us? What do they want from a particular process? And there's a bunch of different types of voices of the customer. Like the voice of the customer, voice of the business, and voice of the quote unquote associate. That's the people that are actually doing the work, right? What do they want out of it? No one likes to go home at the end of the day frustrated, right? So what's the voice of the associate? It's an important component to the project. So these are the voices that are important. It's the people that voice of the customer is the person that pays the bills. The voice of the business is can we prove something so all of us uh, can prosper? And then can we make it where people don't aren't so frustrated with the processes that in most cases they haven't really had a lot to do with designing. They're just forced to work them. So we want to take all those voice of the customers into consideration. And it should be performed methodically. It's very important. There's two popular methods of collecting voice of the customer. One's indirect, the other's direct. Indirect data collection is passive information. It's warranty claims. How many complaints did we have? How many compliments did we get? How many service calls did we have? Um, what's our sales reports? What's our on-time delivery? Those are passive that kind of already happened. Um, and there's direct collection methods, which are conducting interviews, conducting customer surveys. Nobody wants to answer surveys. Nothing like picking up the phone and calling your customer and saying, "Hey, how do we do? Well, how's it look? Are you happy?" Not waiting for the call from them saying, "I got a problem." Direct methods are more effective generally. And again, I think the challenge is, for those of you that want to own your own business at some point in your life, is that I need to be proactive to figure out how to delight, not satisfy. Because if I do all the things that everybody else does, then that's what they expect. That's why they're paying you. Like Chris Rock used to say, I read to my kids. You're supposed to read to your kids. Well, it's kind of the same thing. You're supposed to be on time. You're supposed to deliver 100% quality. You don't get cookie for that. And again, the good news is if you do lean, time, saving people time Time is the currency in lean, and it's a great way to delight your customer when it takes you half the time as it takes your competitor or twice as fast. So gathering the VOC, in order to get the voice of the customer, um, you have to consider many factors, service types, customer segments, manufacturing methods, facilities. It's going to influence my sampling strategy. We're going to cover samples ad nauseum too when we get into the next phase, the measure phase. We need to consider which ones are important and build a sample size plan around them. We want to consider response rates and adjust the initial sample strategy to ensure adequate inputs received, and then collect data using the direct or indirect methods. And then we got to translate that into CTQs. So I have my voice of the customer. How do I translate into things that are critical to quality? Right? There's the VOC. This is what the customer wants. How do I translate that into things that are critical to quality? I'll give you an example of some of those. So CTQ, critical to quality. Now I'm taking what the customer wants, I'm making it quantifiable, measurable, and meaningful. So I have to the hardest thing is quantifying because often it's vague, emotional, or a generalization about products or services. I got to figure out a way to quantify it, right? Um, it can be accomplished by conducting surveys, group sessions, one-on-ones, phone interview, whatever. Um, yeah, it needs to be specific. Um, and some of the tools that we use to identify and prioritize critical to quality include tree diagrams, affinity diagrams, and Pareto analysis. We're going to cover a couple of those in the next section. So a fully developed quality to quality, a CTQ has these components. It has a Y characteristic, it has a measurable metric, it has a target value, and a tolerance range, right? What will they accept and what won't they? What's our range? Um, so let's get into a couple of the tools for CTQ. Affinity diagrams, fun. I'm going to be doing one in a couple of weeks at Marion, actually, with Ulbrich. It's large amounts of soft data resulting from brainstorming. And it's a way to organize all that information into buckets. That's called an affinity. Maybe there's a bunch of people that have done affinity diagrams, so I apologize. This will just be a quick review, but let's say I want to do an affinity diagram to try to figure out why are associates late to work, right? So first step is I want to clearly define the question. Why are they late for work, right? And then here's the key part. I can't do that by myself, right? That's number one. I have to bring in some diversity of thinking. So this is a brainstorming. So we're going to take some time on a sticky note or on a index card and write down everything they could think about of why are associates late to work? They had to take the kids to school, the long line at Starbucks. I had a doctor appointment, the dog threw up, the alarm didn't go off, whatever it is, right? And the more the better. Let those brain waves flow. Once I do that, then I take those and I put them into some common themes. So in this case, it's what are some of the delays at home that cause you to be late? What are some of the delays on the commute? What are kid or pet related delays? And what are delays that are in the building? I couldn't punch in or whatever. The parking lot was full. Too much snow out in the parking lot. Um, and then begin moving the note cards into those themes until all of them are allocated. So they're all lined up nice and pretty. And again, what I'm working toward is just a few vital factors, a few vital X's that I can make improvements on and control. The Pareto principle, this is where our homework's going to be on. I'll tell you, I was not a huge believer of it 30 years ago, but in my own business, it's always correct. Most of the time it's right on the money, but it allows us to focus on the vital few versus the trivial many, right? So what are what are the 20% of the things that have the biggest impact? Right? It means the 80% of the effects come from a few of the causes. And that is Wilfred Fritz Pareto, another fine looking gentleman. Um, but 80% of the defects of a process come from 20% of the causes. 80% of sales come from 20% of the customers. 80% of what people order in a restaurant come from 20% of the menu. And it's like, again, I was like pretty skeptical. I forget which one of the apostles was Thomas. Um, but I tell you, what do I keep in my supermarket inventory out on our shipping? What should we be able to ship at any one time? Well, 20% of the products that we make represent 80% of the sales. 20% of our customers represent 80% of our sales. And if you do the math, particularly if it's a process that's been, years going on, it's pretty close. 80% of your phone calls are made by 20% of your employees. 20% of airports handle 80% of flights. 80% of foods on 20%, like I said. 80% of the information is in the first 20% of a report. 20% of the features of software are used 80% of the time. So a Pareto chart is a modified histogram bar chart. So it's a combination where the data has been sorted in descending order and then displayed as bars. And then that's overlaid by an ascending cumulative line on top. And don't worry about this. Don't hope your eyes aren't fluttering because we're gonna do one pretty quick. But you're looking at a percentage of the total. So the Pareto chart shows the percentage to the total for individual bars, and we're going to be talking about my budget in a minute. Um, Cumulative percentage that also goes on the chart, and that's kind of what it looks like on the right. So we have a regular bar chart, and we have on the right we have a Pareto chart. And again, for people that have already to do this all the time, we've done it many times. I apologize, it's just a review for you, but yeah. I think it's a good way to segue into our math practice part of your program. We're practicing a little bit, but so we're going to make a Pareto chart for homework, and then we'll go next week when we'll cover the blue stuff starting there. So let me switch over. How are we doing? 10 of, not bad, still good time wise. We're going to go into math practice, which is again something you're going to see every single week, pretty much. And you'll see there's your name, there's your company, and the first homework is right here in column C, Pareto. So you can watch the recording because I'm going to go ahead and do it right now. This is what you're going to get. The problem is I'm broke. I'm upside down with money. Um, my monthly expenses are $6,125, and my monthly income is only $5,100 a month. So that means I'm in the hole $1,025. So the assignment is to draw a Pareto chart with cumulative totals and make a recommendation. Okay, so in other words, you're going to play my financial advisor. All right. So the first thing I got to do, you can see it's steps 1 through 7 here. And again, you can watch this recording and just walk your way through it in Excel. Because what I'm going to do is I'm going to send you this whole thing, right? What you're looking at right now. And then you're going to send it back to me before our next class. Which, by the way, because I'm going to visit my kid in San Diego Thursday through Monday, I'll be flying Monday. So our next class won't be for 2 weeks. I apologize for that. I should have told you that earlier. But I have an opportunity to go out and see my Navy guy and his wife. First thing to do is sort data largest to smallest. So here's the data. These are all the reasons. I've been married to the same woman for 40 years. So you know this is all fake stuff, but my alimony is $285. My credit card, $480. Food, eat out. These are all the things that I spend my money on. So the first thing I want to do is I want to sort them from largest to smallest. And the easiest way to do it, because what I'd like you to keep in mind is there might not be simply this many 14 pieces of data. It might be 14,000. And I could just do the same steps. Same steps, whether it's 14 or it's 14 million. First thing I'm going to do, I'm going to highlight everything because it says here on step one, use the data filter, right? So basically, after I highlight it, I am going to go, I got to move my, I'm going to go to data and filter right there. And now you see the little arrows that just got introduced in each column. And now if this was 14 million pieces of data or 14,000, it would be tough to go ahead and sort. But here, I just click that little arrow and I sort largest to smallest. Woohoo! So 1180 got on top. That's my rent. And what I'm putting together, the savings, I don't know why I put $5 to savings if I'm hemorrhaging $1,025 a month. That's the lowest one. Now, the next thing I want to do is I want to do the cumulative total. That's step two. So same thing. I'm going to click into this first box next to the 1180, and I'm going to use the function equals. We're going to use a lot of the equal sign. And all I'm going to do is take that and go equals. The first one is going to be equals 1180. So it says equals B9. So that's column B, row 9. Hit enter. And there my 1180 goes there. Now the cumulative total means I want to add that 1180 to the next one. Okay. I want to add the 1180 and then add the next one, then add the next one, then add the next one. So this one will be equals 1180 plus, so I have to hit the shift arrow and the plus sign, 875, and that equals 2055, right? 1180 plus 875 is 2055. Then I don't have to do it for the next 14 million of them. It's going to find this little box on the corner of this cell, the 2055 there, until it turns into like a cross and double click it. And then it's going to go ahead and fill in whether it's 14 values or whether it's 14 million values. And the last value better be 6125 because basically, and that's what it is. See, that's where my monthly expenses are. So they better add up to that. All right, 6125. Then I'm going to do the cumulative percent. And that is, I want to get the percentage of the total that each of these represents. Right. So again, I'll start with equals. And I'm going to capture the 1180 first. And then I'm going to divide it. And that's with just a forward slash, is that? The division. And I'm going to type in 6125. What percentage of 6125? Hit enter. And I know that that's 19% of my total budget of 6120. Not total budget, my total expenses. Double click. And that last one better equal 100, right? Because we'll cumulatively be adding on. So, all right, now I'm going to turn it into a Pareto chart. And so you can see that step 4 is I'm going to highlight. So largely I hit the control button and left click mouse, column A, and column B, the amount, and column D, the cumulative percent. And again, folks that haven't spent a ton of time in Excel, this might take a little bit of practice in terms of how you're moving your mouse and all that. Stay with it. It'll get really easy after a while. Then I'm going to hit, let's see, I'm going to put in insert up top. I'm going to put it, and it's going to say recommended charts. I don't, oh, I highlighted one that's not there. I apologize. Let me do it quick. You see that little one? That's why I didn't let me do my chart because it's going to try to chart that too. So it's doing the same. Man, oh man. A, B. Don't get old, people. No, you should. It's better than the alternative. The recommended charts. Second one down. Bada bing. There's my chart. And I click on chart title. Put a title on there if I want. Bills. Broke. There. That's Pareto chart. All right, so that's how you're doing. And then the assignment's going to be after you've done this, make a recommendation. And the second question, the thing I'd like you to answer is the does Pareto hold water here? In other words, is it true? Is it 80/20? All right. Ta-da-ding! So 256, not bad. Anybody any questions, thoughts? Everybody's awake? Woohoo! All right, I'll send you the recording, the slides for Define, and the homework. And then you have 2 weeks to do it. Don't, guys, I recommend, if you when you get the homework, don't wait long. You know what I mean? Get in the habit of doing it right away because it won't take you long at all if you do it right away. And if you get more than 2 homeworks behind, I'm probably going to ask you to take the course over in the fall if you want to, because it's once you get behind, it's just if you do it quick and you do it easy, you got to get into that find time to do it. 15 minutes. It'll take you no more than 15, 20 minutes to do it. If you have problems, if you're struggling, um, I'll see a lot of you guys during the week when I'm with you, I'll do it with you. If you have questions, just send me an email, send me a text, and I can touch base with you and we can do it together. I want to make sure you get, and this one here, this was a demonstration that, just getting into the workflow of here's the Excel file, you guys get it back to me. Then when you get it back to me, I put the X on that big grid with your name on it, and then we make it all green. At the end of the day, it'll all be green. So, any questions, thoughts? Sorry about all the bit in the beginning. That's unfortunately that's part of it. All good, everybody? All right. Have a great night.
Thanks, Bill.
Yep.
Thanks, Bill.
Hi, guys.
Later, Bill.